Hi there, thanks for joining me today. I have had a look at your resume, and it looks like you have been working with Flutter for about 2 years now. To start things off, maybe we can just dive right in with some basics. Could you explain the fundamental difference between a stateless widget and a stateful widget?
Sure, I would be happy to. At a high level, the difference comes down to whether the widget needs to change its appearance or its data while the app is actually running. A stateless widget is exactly what it sounds like. It is a widget that does not change once it is built. I usually use these for static parts of the UI, like a simple label, an icon, or a decorative container where the data stays the same throughout the life cycle of that widget.
And the stateful widget?
A stateful widget is used when the widget needs to be dynamic. It has a special associated state object that allows it to rebuild itself when something changes. For example, if I have a checkbox that the user can toggle or a screen that needs to update when data arrives from a server, I would use a stateful widget. When the state changes, we call setState, and that tells the Flutter framework that it needs to redraw that specific part of the UI to reflect the new data.
That makes sense. Since you mentioned the redraw process, let's talk about the structure of the app. Could you describe the concept of the widget tree in Flutter?
Definitely. The widget tree is essentially the fundamental structure of any Flutter application. In Flutter, every single element you see on the screen is a widget, and these widgets are nested inside one another. You can think of it like a family tree or a hierarchy. For example, at the very top, you might have a root widget like Material App. Inside that, you have a scaffold, which provides the basic layout structure. Then, inside the scaffold body, you might have a center widget, and inside that center widget, you might have a text widget. Because they are nested this way, they form a tree. The beauty of this system is that when the state of the app changes, Flutter doesn't necessarily redraw everything from scratch. It identifies the specific branches of the tree that need to be updated and redraws only those, which is why the apps stay so performant.
Speaking of performance, Flutter is often praised for being faster than traditional WebView frameworks or some other cross-platform tools. In your experience, how does Flutter actually achieve that high performance?
From what I have learned and experienced, the key is that Flutter doesn't rely on native system UI components or a browser bridge to render the interface. In a lot of other frameworks, the app acts as a wrapper that sends messages across a bridge to the native platform to say, hey, create a button here or make a list there. That communication overhead can cause lag. Flutter skips that middleman entirely. It uses its own rendering engine, like Impeller or Skia, to draw every single pixel directly onto a GPU canvas. It compiles its code to native machine code, so it handles the rendering itself. This allows it to maintain a very consistent 60 or 120 frames per second, because it isn't waiting for a bridge to tell the OS how to draw a widget.
That is a great technical overview. Let's move into the lifecycle of these widgets. You mentioned statefully widgets earlier. When exactly is the initState method called in a stateful widget's lifecycle?
The initState method is called exactly once when a stateful widget is first inserted into the widget tree. It happens after the widget is created, but before the build method runs for the first time. Because it only runs once, it is the perfect place for one-time setup tasks. For instance, if I need to initialize some variables, start an animation, or subscribe to a data stream, I put that in initState. I avoid putting that logic in the build method because the build method can be called many times by the framework, and we definitely don't want to restart our animations or resubscribe to streams every time the widget rebuilds.
That's a common pitfall for beginners. Since you're talking about initialization, what about the other end of the lifecycle? How do you handle widget disposal and memory cleanup in a stateful widget?
To handle cleanup, you have to override the dispose method. This is part of the state class and is automatically called by the Flutter framework when the widget is permanently removed from the widget tree. Inside the dispose method, I manually call the dispose method of any controllers, streams, or timers that I created in initState. This is absolutely critical because these objects often hold references to the state or use system, resources that the garbage collector doesn't automatically clear. If I forget to dispose of a text editing controller or a stream controller, it creates memory leaks. Over time, these leaks can slow down the app or even cause it to crash. My general rule of thumb is that any object I initialize in initState that has a corresponding dispose method must be closed in the dispose method.
Very clean. Now, I want to touch on something a bit more conceptual. Many developers get confused between the widget tree and the element tree. Can you explain the concept of BuildContext being tied to the element tree rather than just the widget tree?
This is one of the more interesting parts of Flutter's architecture. In Flutter, widgets are actually just blueprints. They describe what the UI should look like, but they are lightweight and get destroyed and rebuilt all the time. However, the element tree is the actual persistent structure that manages the lifecycle of the app. BuildContext is essentially a handle to a specific element in that element tree. When a widget is created, Flutter creates a corresponding element to manage it. This element is what actually knows where it sits in the hierarchy and how to find other elements above it. Because the element tree stays stable while widgets are being swapped out, BuildContext allows us to look up the tree to find global information, like the current theme or navigation data, by searching through the element tree rather than trying to navigate a static list of blueprints.
I like how you distinguish the blueprint from the actual element. Let's switch gears to layout. In a typical UI, when should you use a row versus a column? And how do the main and cross axes work in those contexts?
Basically, I use a row when I want to place widgets side by side horizontally, and a column when I want to stack widgets vertically. The concept of the main axis and cross axis is key here. The main axis is the primary direction of the widget. For a row, the main axis is horizontal. For a column, the main axis is vertical. The cross axis is always perpendicular to that. So in a row, the cross axis is vertical, and in a column, the cross axis is horizontal. When I'm positioning children, I use main axis alignment to move them along that primary direction and cross axis alignment to position them across the opposite direction. For example, if I want a set of icons in a row to be centered vertically, I would adjust the cross axis alignment.
Now, let's talk about something more advanced. Have you encountered the LayoutBuilder Paradox? Can you explain what it is and why it causes infinite constraint loops?
Yes, I've run into that a few times, and it can be frustrating if you don't know why it's happening. The LayoutBuilder paradox occurs when a widget tries to determine its own size based on the constraints provided by its parent, but those constraints are themselves dependent on the size of the child. In Flutter, the rule is that constraints go down and sizes go up. The parent tells the child what the limits are, and the child tells the parent how big it wants to be. A loop happens when you place a layout builder inside a widget that provides unbounded constraints, like a list view or a column. If I use the layout builder to set a specific size for its child that then triggers the parent to change its own constraints, it creates a cycle. The child asks for the size, the parent gives a flexible constraint. The child decides on a size based on that, and then the parent recalculates because of that size. It never reaches a stable state, which leads to an infinite loop and usually results in the app crashing.
That's a great explanation of the layout flow. Let's move over to data and networking. What is your recommended way to handle API calls and JSON serialization in a Flutter project?
I'm a big believer in separating logic into layers to keep the project maintainable. For the actual networking, I typically use a dedicated client like the DO package or the built-in HTTP package to handle the requests. For JSON serialization, I try to avoid manually mapping maps to objects using the map operator, because that's where a lot of typos and runtime errors happen. Instead, I use a model class with a factory constructor, or for larger projects, I use code generation tools like JSON Serializable and BuildRunner. This ensures that the data parsing is type-safe and consistent across the whole app. In terms of the flow, I trigger the API call in a controller or a provider. That layer manages the state of the request, so it can tell the UI whether the request is currently loading, if it was successful, or if it failed. This way, the UI just listens to the state and doesn't have to worry about the details of the HTTP request.
You mentioned the logic layer. Could you expand on the concept of separation of concerns in a Flutter architecture? What does that look like in practice?
Separation of concerns is really about dividing the program into distinct sections so that each one has a single responsibility. In Flutter, I aim to keep the UI layer, the business logic layer, and the data handling layer completely separate. The UI layer should only be concerned with how things look. It shouldn't know how the data is fetched, it should just know how to display it. The logic layer or the business layer handles how the app behaves and processes data. Then the data layer manages the actual fetching and storage, whether that's from a REST API or a local database. By doing this, the code becomes much more flexible. For example, if we decide to change our backend from a local file system to a cloud API, I only have to modify the data layer. I don't have to touch the UI or the business logic at all. It makes the app way easier to test and scale, because a change in one area doesn't cause a random crash in another unrelated area.
Speaking of data, let's talk about Dart specifically. What is a future, and how does it relate to asynchronous programming?
A future in Dart is essentially a promise that a value will be available at some point in the future. In asynchronous programming, we deal with tasks that take time to complete, like downloading a file or querying a database. If the app just waited for these tasks to finish synchronously, the entire user interface would freeze, and the user would experience a total lockup. A future allows the program to start that task and then move on to other things. Once the task is actually done, the future completes and delivers the result, or it returns an error if something went wrong. It represents a potential value that will be delivered eventually.
And how do you actually handle those asynchronous operations in your code to keep the UI from freezing?
The most common way is using the async and await keywords. When I call a function that returns a future, I mark my function as async and use await before the call. This tells the app to pause the execution of that specific function until the operation is finished, but it doesn't freeze the main thread. The UI remains responsive. To actually get that data onto the screen, I usually use a future builder widget. It's really convenient because it automatically rebuilds the UI based on the snapshot of the future. It gives me an easy way to show a loading spinner while the data is fetching, and then switch to the actual content once the data arrives, or show an error message if the request failed.
Let's talk about a more complex scenario. What if you are receiving high-frequency data streams, like location updates or a real-time sensor feed? How do you ensure the UI remains responsive and doesn't overload the main thread?
High-frequency streams are tricky because if you trigger a full widget rebuild every time a new data point arrives, you'll definitely see stuttering or a drop in frame rate. First, I make sure to wrap only the smallest possible widget that needs the data. I use a stream builder, but I keep it very localized so that the rest of the page stays static. To further prevent the main thread from choking, I implement throttling or debouncing. I often use a package like rxDart for this, which lets me limit how often the UI actually updates, regardless of how fast the data is coming in. And if the data processing is actually heavy, like if I need to do complex calculations or parse a huge JSON string from that stream, I offload that work to a separate isolate. Since the main thread in Flutter handles both rendering and logic, moving the heavy lifting to another isolate ensures that the frames per second remain stable and the app doesn't lag.
You mentioned debouncing. Can you explain how you would implement debouncing for a search box to prevent API rate limiting?
Right, debouncing is specifically used to delay the execution of a function until a certain amount of time has passed since the last time it was called. If a user is typing a search query, they might type 5 or 6 letters very quickly. We don't want to fire off 6 separate API calls for every single keystroke, as that wastes resources and might get the user blocked by a rate limit. In Flutter, I usually handle this using a timer object from the Dart async library. Every time the user presses a key in the search field, I cancel the existing timer and start a new one for, say, 500 milliseconds. The API call only actually triggers if the timer finishes without being reset. This ensures that we only send the final request after the user has paused their typing.
That's a very practical implementation. Let's talk about the tools and ecosystem. How does package dependency management work in Flutter, and what is the role of the pubspec YAML file?
Dependency management is handled by a tool called pub. It's great because it allows us to use libraries created by the community instead of writing every single utility from scratch. The pubspec YAML file is essentially the manifest for the project. It's the central configuration file where I list all the packages the app needs, the specific versions I want to lock in, and other assets like images and custom fonts. When I run the Flutter pub get command, Dart reads that YAML file, downloads the correct versions of the libraries from the pub, dev repository, and then creates a lock file. That lock file is important because it ensures that every developer on my team is using the exact same version of every dependency, which prevents those weird bugs where things work on my machine but not on yours.
I've seen a lot of projects use keys. What is the purpose of the key parameter in Flutter widgets, and when is it actually necessary?
Keys are used to uniquely identify a widget within the widget tree. In most cases, Flutter manages the UI automatically, and we don't need to worry about them. However, keys become necessary when you have a list of widgets of the same type, and you need to move, remove, or reorder them. Without a key, if you remove an item from a list, Flutter might get confused about which widget is which when the state changes. It might accidentally keep the state of the old widget and attach it to the new one in that position. Essentially, keys tell Flutter exactly which element in the UI corresponds to which piece of data in the background. This ensures that the state is preserved correctly during updates, especially when dealing with items that have their own internal state.
Let's move into some more specific UI components. Can you explain the concept of sliver widgets? Why would someone use them instead of a regular list view?
Slivers are specialized widgets that represent a portion of a scrollable area rather than the entire view. A standard list view treats the whole list as one big block, which is fine for simple lists, but it's limited. Slivers allow you to break the scrollable area into smaller pieces that can each have different scrolling behaviors. This gives you much more precise control over how elements enter and leave the screen. For example, if you want to create a collapsing app bar that shrinks as the user scrolls down, or if you want to mix a grid and a list within the same scrolling view, you would use slivers. You coordinate all of these using a custom scroll view, which acts as the manager for all the sliver children.
That's a good explanation. Let's talk about navigation. How do you handle moving between screens in a Flutter application?
Navigation in Flutter is handled by the Navigator widget, which basically operates like a stack of pages. To move to a new screen, I push a new root onto the stack, which places the new screen on top of the current one. When the user wants to go back, I pop the current root off the stack and that reveals the previous screen. For very simple apps, I might just pass the widget directly into the push method. But as an app grows, that becomes hard to manage. For larger projects, I prefer using named roots. This is where each screen is assigned a unique string identifier in the app's main configuration. It makes the code much cleaner and allows you to navigate to a specific screen from anywhere in the app using just a string identifier.
Now, let's go back to development workflow. What is the difference between hot reload and hot restart?
Both are used to see changes quickly, but they work differently. Hot reload injects updated code into the running Dart virtual machine and maintains the current state of the app. So if I'm on a specific screen or I've typed text into a form, that state stays exactly as it is, and I can see my UI changes instantly. Hot restart is more thorough. It completely destroys the current state and restarts the app from the beginning. I have to use hot restart whenever I make changes to global variables, static fields, or the main function, because those aren't covered by the hot reload process.
Last question for the technical portion. You mentioned the layout flow earlier. Let's go back to that. If you are working with a column and you want its children to be centered both vertically and horizontally, how would you achieve that?
To center children in a column, I would use main axis alignment. Since the main axis of a column is vertical, I would set main axis alignment to main axis alignment.center. that handles the vertical centering. For the horizontal centering, since the cross-axis of a column is horizontal, I would set cross-axis alignment to cross-axis alignment center. However, I also need to make sure the column itself is filling the width of its parent, or I would wrap the column in a center widget to ensure it's positioned in the middle of the screen.
That sounds correct. I think we've covered a lot of ground today, from the basics of widgets to more complex topics like isolates and slivers. I've really enjoyed hearing your thought process. Do you have any questions for me about the role or the team?
I do, actually. I'm curious about the current state of your project's architecture. Are you using a specific state management library like Block or Provider, or are you leaning more towards a custom solution?
We actually use a mix of Block for the core business logic and Provider for simpler UI state. We've found that combination gives us the best balance of scalability and simplicity. We're also in the process of migrating some of our older modules to a more layered architecture, similar to what you described today.
That sounds like a great approach. I've used both Block and Provider in my previous projects, and I find that separating the heavy business logic from the UI state really helps when the team grows.
Definitely. Well, I think that covers everything for today. We'll be in touch soon regarding the next steps. Thank you for your time.
Thank you very much for the opportunity. I look forward to hearing from you.